Okay, so we're going to use this session to talk about a number of key basics with Java that I see as kind of very, very important for understanding what's going on in any logic. One of the core concepts to be discussed here is the notion of value in Java. So when we put in a number for something like the average number of connections per agent, we put in a number for something like someone's income or someone's sex. These are all examples of values. So a single quantity, it's typically something like a number or a reference. And values can be of different sorts. So there's integers, there's floating point values, which can be either sort of shorter or longer, so-called double precision. Characters like this, booleans, and references to objects, so a reference to a particular person, or a reference to main, or a reference to a collection, or something along those lines. So we have values that circulate in the model. A Java expression is like a formula. It computes or evaluates to a value, typically based on other values. So it takes a bunch of values, say, takes A and B and adds them together to get a value. So it takes a value from A, a value from B, and adds them together. For years you've probably been writing expressions using algebra, using them in Excel, and calculators. So in Excel you say this cell is the sum of these cells, or this cell is that cell minus that other cell. The contents of this cell minus the contents of that other cell. So you're dealing with formulas that manipulate values. So the values in Excel are the contents of the cells. The values in any logic are things that live in variables or parameters or that are entered directly by you. So we have expressions that are things like this: A plus B times C, or A greater than B. These things are expressions involving values, and they themselves have a type associated with them. So this is, for example, evaluates to what? Can anyone tell me? Is it a double? Is it an integer? Is it a reference? It's an integer. This is an integer operation, involves 2 and 5. Now that may seem kind of prosaic, so it evaluates to 10, but if this had been 2 divided by 5, it's very relevant that these are integers, because what would that give? It's an integer operation, because it's operating on integers here, so 2 divided by 5 would give 0. It actually rounds down. Okay, so that would actually give 0. Maybe I should, for future cases, I should probably mention that, because it's something that it's one of the key things that bites people, including computer science students, bright-eyed and bushy-tailed, bitten by that, and sometimes they're not so bushy-tailed after that. Let me put in that quote there. So that's worth understanding. On the other hand, this 1.0 divided by 3, what sort of operation is that? It turns 3 into a floating point number, so it's a double. It turns it into a double of floating point, and so it ends up being a floating point operation. So this is approximately 0.33333. So Shirley, you were going to say something?
I was just going to ask if you specified someplace, because sometimes you specify whether it's a double or an integer or whatever it is. If you specified that it's a double, and then you go 2 divided by 5, do you still get 0? Or do you, because it's 2 divided by 5 and not 2.0 divided by 5?
So if you wrote 2 divided by 5, it says these are integers, so therefore they must mean divided by an integer.
Even if there's someplace else in any logic that just above that or whatever that said, okay, I see.
So you could actually say there quite explicitly, like if you wanted to...
If you'd already told it it's a double low.
Right. That's right.
Floating point or whatever.
You could, for example, do this, Cheryl. You could say double of 2. And that means that says basically treat it as a double, like turn it into a double.
All right.
In which case, then it would do that.
Something like that greater with an integer because it would cooperate.
Oh yeah. So you can do that. You could say basically, hey, turn this into a double precision value. This also gives back a value. This dot get connected agent this is a value, it's a reference. It calls off to this method, it returns another value, which is a reference, which is a reference to a different agent, and then it asks for that name, which is a value, it's a reference to a string, in other words, a string of characters. And so that's a value, it's a reference to a string that results to this big computation involving a number of different values. There's a value for I here that's used as some integer. So in the process of computing a value, it may call off the methods. It can even change what's currently the state. For example, certain expressions can, for example, assign one number to another. That's actually an expression in Java, even though it does something, and it doesn't just compute something, it actually changes something. It's also an expression. It computes a value. So A equals 2, for example, is actually an expression. It actually, the value of A equals 2 as an expression is 2, but it also changes what A is. Changes the variable A. It actually modifies that. But it also, its value is 2, the result of that. Calling a method is also something, so calling this function, it's actually something which can do a lot of work. It may change what's shown on the screen or what have you. So in most places, one of the reasons I'm telling you this about Java expressions is because there's a lot of places in any logic where any logic wants value. You need to tell it a value, and in general you can put an expression there instead, okay? So most of these places here, if we go to, we go to one of these models we built up, just to show that it's fairly ubiquitous. If we go to agent here, for example, if we want to put in coordinates here for x and y, or if we wanted to go to agent and we want to look at their income, this place to put in default value here, I could put an expression there, any expression. All it has to do is compute a value. So it could be 1,000 divided by 5. It could be A divided by 4. It could be sex times, 20,000. It could be a call to a method. So that's an example of where these things go. This would be, where else? Well, where else in this diagram here would I expect to see an expression? Something that where I can put a value or I can put an expression, something that computes a value. Where else would you expect to see that? Yeah, transition, exactly. So, for example, with this transition here, I can't remember. It's a rate transition. This is where an expression goes. I could put a direct value there, but anything that computes a value, I could put there too. So I could compute, put A divided by 4. Yes.
So, for instance, if under income you wanted to do something, if you had another parameter in there, like tax rate,
Yes.
you could say, pull from this table
Exactly.
and minus tax rate or something
Yep.
like that.
Yep.
Okay.
Yeah, exactly. Now, if you have multiple parameters, you've made the value of one parameter depend on another. You have to be a little bit careful about which order they're computed in, like which is available first. But yes, in general, you could have it depend on a schedule of tax rates here and look up the person's age and sort of get the tax rate for them and look at their what have you. You could have another parameter or a value that gets the tax rate for that income level or what have you. So you can do that. Now, just in case, so there's no mystery here, and I don't mean to scare you folks, but again, I can always control J, and I can see where that value goes. So that 0.1, this is where it goes in any logic code. So this is what's produced. I don't spend virtually any time looking at this, but occasionally it's useful to see, like, where is this actually going? That 0.1 is actually in a statement, which is a different class of thing we'll talk about in just a few minutes. Expressions, statement. Statements do things. Expressions calculate values. Here, this is an expression, a value, so just the value itself, in a statement, a return statement. And what this is saying is, when you call this thing evaluate rate of this transition, it will return 0.1. That's where that goes if we ever want to use it. So these things are ubiquitous, scattered around. This is also an expression here for color. I actually don't have an initial value, so it's not set to anything, but here, I'll have a value here for it, green. That's actually a value. It knows what that means. It's some reference to a color called green in capital REEN. Okay. So here's some common Java expression. This is an expression, 3.5. My string is an expression. This is actually expression in brackets. Anyone want to guess what this means? If I see those curly brackets, what are those? Seems kind of weird. It's an array. It's an array of values, actually. Exactly. And that's actually, Java knows what that means. It says, oh, this is an array of a bunch of values. Null. Remember, where did we see null before? What sort of value was that? Where does that come in?
We're missing something, right?
Yeah, we don't have a legitimate pointer. If our reference is not, it's not to anything, it's to nothing. It's like saying, you know, this job is occupied by nobody right now. We might say it's occupied by a person whose value is null. So it's distinct, saying it's not occupied by anyone. This is referring to nobody. Okay. These are expressions: a greater than b, a equals b. And there's times where you'll put that into any logic. We'll see tomorrow this very useful thing called a statistic. You folks haven't seen it, but I'll give you a sneak preview. This is a bonus of coming to this tutorial. Watch the sneak preview. There's something called a statistic here, and we can add a statistic in. Do add statistics, and you'll notice we could count up the number of people who match some condition. Okay, so we could say, well, their condition is that their income level is greater than, is less than $10,000. This is an expression. It's something that evaluates to true or false. That's the condition here that's used. Okay, so this is a type of expression. Where did we see, there's something called a ternary operator. Where did we see this before? Some condition, question mark. So this is something that evaluates to true or false. A greater than B, for example, A equals B. Is this, is some other test, question mark, A colon B. Where did we see this before? You remember? Sorry? Yeah, it's sort of, it's an expression. It's not a statement, it's actually an expression that computes, but it's like an if, it does either one or the other depending on this value of this first thing. This first thing has to be, it's a predicate, it evaluates to true or false. And either this is true or either we have A or B. So in other words, the value returned by the ternary operator is either A or B. Which one it is depends on whether this predicate is true. For example, maybe we have, if sex equals 0, question mark, blue, colon, pink. In other words, if sex is equal to 0, the value of this whole thing is blue, otherwise it's pink. So that was an example where we saw that at one point in the dynamics. Okay, so these are common Java expressions. And why am I showing these to you? Because there's lots of places in any logic where it's asking for an expression. You can't give it a statement. You have to give it an expression there. Something that computes a value. And these are all examples of computing values. Do not be caught into the thinking that you can only put a number. You can in general put any of these things, and they can be very complex expressions. But, ladies and gentlemen, if you have complex expressions, that's a sign that it's time to maybe put it into a function, then you can call that function. And we'll talk about functions in a separate time. Okay, just wrap it up, give it a nice name. What does it mean, this expression? It does. It computes something, give it a nice name that shows that. You can just call it, and then you don't have to look at this god-awful, ugly expression. This is one of the things that really, my stomach feels queasy when presenting to the boot camp, because sometimes I show things there that I would normally put in a function and just call a nice named function, and it makes me queasy to show you long expressions because they make me cringe, and they probably make you cringe as well. Here's some additional ones: A and B. You'll see this occasionally, where you'll see A this sort of bar B. This is a logical and. In other words, if A is some condition, x is greater than 0, and maybe B is another condition. Maybe it's x is less than 10. Then this is only true if, in other words, if x is in the range from 0 to 10. So if you had, for example, this is a common one. You'll actually see it in some of the models in AnyLogic, something like this. And x is less than 500, something like this, less than or equal to, say. What this is saying is x is between 0 and 500. It's both greater than or equal to 0, and it's less than or equal to 500. Okay. A or B. So it's either greater than 0 or it's less than that. That would be a different condition. You'll find this $sign. This means logical not. So if you say not of it, if you said something like, not of this. Let's suppose I did this. How if I did that? What would that mean? What this is saying is it's taking the opposite condition of what's in here. So at an intuitive level, what would this later one mean? It's less than 0 or it's greater than 500. In other words, it's not between 0 and 500 inclusive. It's something outside that range. Okay? So that's good. Here's another one. If A is an array, we'll see. It's kind of like a vector set of numbers, sort of one after the other. If we have A subscript 20, what that means is it's the 21st item in that array. Why 21st? Because you start with 0. 0, 1, 2. This is a tension between computer scientists and mathematicians. And I'm caught in the middle. But A will start with, if this is an array, it'll start with index 0, and then index 1, and index 2, index 3, index 4. And if it's of length 25, it'll go up to index 24, 0 through 24. Just like if it's of length 1, it's only index 0. So this is a little bit confusing. And that's why you get connections number, and so you subtract off 1 from it to get the last item if this entire array is of length, get connections number. Okay, so these are some common expressions. Call F to 2 and 3. For strings, one string plus another string. What does that mean? It means to concatenate them, put them right after each other. Where did we see this? We actually saw this once or twice in my examples. Do you remember where that was? Trace ln. We said like trace ln. My mother's name is plus mother. And what was actually going on there? This was a very clear string. The other one, because this was a string, this one got converted to a string automatically. So like, my mother's name is this, and the other thing was a reference, mother. And it said, oh, this is a reference. Well, to really apply this concatenation, I need to turn the second one into a string. This is called promotion in programming languages, or it's a bit different from coercion, but it's called type promotion. There's another name for it, it's very similar that I can't remember right now. And it turns it into a string and puts it together. And this is why if you have something like 2.0 divided by 5, it'll actually turn the 5 into a double precision value because the other one already is. It promotes it to be that. Same thing with strings. So if you had, person string plus their income, my income is, in quotes, plus income, name of the value, which is a double precision value, you'll turn that into a string. So you can do this very readily in AnyLogic. Okay? These are common operators. Okay, so how do you read Java expressions? It's very important to develop this skill of reading them. You read them from sort of inside out, to sort of understand what they're ultimately returning. You go from the inside out, you go successfully longer until you read sort of the last thing here. So you start with A. A is a reference here. A is a reference to a person, perhaps. or just some agent. And on A, you call get connected agent with some value. Maybe it's the I is 0, so it's the very first person they're connected with. That returns a value. And then on that value, you call get name. That returns a value. It's a pointer to a string. And then you ask for that length, and that returns a value, which is the length. So you kind of read it left to right, inside out, and to understand the entire value that it performs. And these expressions are routinely strung together in this way. But if they get too long, don't do it. Give it a nice name, break it up into pieces so it's more obvious. If you string them together too long, it just, your eyes start to glaze over. So it's really nice to sort of say, you know, person P, you know, person my friend equals a dot get connected agent. Introduce a variable called my friend, and you say equals a dot get connected agent. And that's a statement. And then you say my friend dot get name dot, you know, my friend string my friend's name equals my friend dot get name. And then you say string dot length, or you say my friend's name dot length. So it'd be better to break this up into pieces, and we may see some examples of that. Right. So this gets into this issue of a variable declaration. So we often want to keep a nice name for a value. Give a value. You want to give it a name, a nice name that you can refer to easily. Instead of giving a long expression every time you want to give it a name like a name like my friend. You can create a variable and give that variable a name. So this is an example of a variable in some code. Double x equals get x. This value x is getting my current location, get x. What's omitted there is this dot get x. That's automatically interpreted. Java will automatically stick that in. If you don't put this dot, it will automatically do that. So this is giving a nice short name for my current location. Everywhere I use x here, I could put in get x. As long as my location hasn't changed, it would be the same. I could put it all down there, but it's really nice to be able to give it a nice name, a short name. Similarly, I could call main m. So instead of putting this dot get main in all sorts of places, I could just refer to m dot instead of this dot get main dot. Okay. Another thing I could do is I could refer to, you know, a person and give a name person P equals this dot get connected agent of 3 or something like that, and give a nice name for my fourth connected agent connected to me. So here's another example. This is a variable C. It's an integer which is computed with this thing here, another variable, and then I can just use C and R. Now, I could have substituted this whole thing into each of these places where C is used, but it would have been god-awful ugly. And it would have been confusing, and it would have been buggy because I might forget to change one when I updated the others, and it would just be horrendous. A lot of the art of writing this is to make it simple, clean, and transparent. So you do that by creating little variables here in code. So these are expressions here. They evaluate to a value, and you're assigning that value a nice name, giving it a name so you can refer to it later. You could use that value again and again and again. So here we give nice names to things. So we can give short names using variables. Now, when we do that, we have to state what's the type of this variable. Maybe this is a double, maybe it's an int, maybe it's a person, okay? So, or a string. And so we have to say, before the variable name, we have to say like person P equals this dot get connected agent of 0, something like that, okay? And then we can refer to that person as P from now on. Refer to that same person as P, okay? So this is what we call a variable declaration. It declares the variable. From then on, we can use it. We can refer to it. So here's M, for example, being used from here. Here's M being used. And here's M being used. If we had to put get main here, it would just make it really kind of clunky. We just have to have all this text around. This cuts down the text. Imagine if we had to have this in lots of places. It'd be messy. So these declare variables have a value in them, and we use that value. Any questions about that? Are people comfortable with that? You see a similar thing in languages, many other languages. You have a variable, give it a brief name. Have anyone in here used R before? Yeah, okay. So in R, you give a variable and you assign it something. Now in R, you don't have to give it an explicit type. R takes kind of care of that. But here, to double check things, that you're not mixing some weird way a string with a person, or and you're not making an obvious mistake, you need to declare the name of it, okay, and or the type of it, and then that allows it to check your model for consistency at a greater level than if you didn't give it a type. If it didn't know what it was, it can't check it as well. Okay. Okay. I think I'll leave that. Right. I think I'll sort of skip over these things. Just be aware that Java variables can occur. So variables hold values. They hold values. Values are computed by expression. That's what we've sort of been describing. Variables can come from many different places in Java. So they can, for example, live in parameters. They can live in a thing called a variable in Java. They can also be included in certain things called functions in Java. So we could have, for example, a function here that says, something like, disappear. So this might be a variable, and I can give it some information that I want it to use. Or I could, maybe this variable is like promotion. Promote me. So I promoted myself to a higher level of income, and maybe there's a parameter, a variable passed to me called bonus, the size of my bonus. And when I get this bonus, you know what? This is in main. I meant this to be in person. Look at that. That's a rookie mistake. Hey, come on. Copy. I just copy it and put it down here. Here we are. So now we have a function here called promote me. Oh man. No end of trouble here. Promote me. And I take in a bonus level that's going to be a bonus. It's a CDI. It's an increase in my income. And so what I want to do is income plus equals bonus. And from then on, that will be added to my income. By the way, this plus equals, does anyone know what that means? Okay. What this means is income equals income plus bonus. That's what it means. In Java, you will see this quite a bit. You'll see plus equals, so A plus equals B. And all that is a very brief way of writing income equals income plus bonus. Okay? It's brief, and often it's really nice that it's brief because it makes it very clear, okay, this guy is being incremented by bonus. Okay?
Is that kind of expression, is that covered in something like Java for Dummies?
Oh yeah. Yeah.
Is that, what do you recommend?
I think Java for Dummies is not a bad one. There's another one called the Big Book of Java that's not bad, by Kay Horstman, and I would recommend that book as well. It's pretty good, but it has a lot of things you won't need. Big Book of Dummies, or sorry, Big Book of Dummies, no. Yes, the other book is I think it's not bad, and it would be covered there. Okay. Another one that you'll see a lot is this income plus plus. Does anyone know what that means?
It's income squared.
No, it's close. It's kind of close. It's income plus equals 1. In other words, just increment by a single value. It's by exactly 1. Okay. And minus can also be used. They're most commonly used with integers. You want to increase it by 1. But there's also, just to sort of confuse things a little bit, there's plus plus income and minus minus income. And the deal here is, for code that you do, I would urge you to put this on a separate statement, but if you do something like if plus income is greater than 10, then what that's going to say is it's going to take income, check if it's greater than 10, but if you sort of get its value and compare it, it's going to increment it. So in other words, it's going to increment it, but that's not going to affect whether or not it was true when you compared it. So you get the value from it, and you got that, you're about to compare it to 10, it increments the value of income, but you compare the value as it was before the increment here. Okay. And so maybe income's level was 9. Maybe income's level was 10. If income's level is 10 here, if income equals 10, this thing will actually be true, and so it'll execute whatever inside the if statement. Some code. It'll execute that code if income equals 10, because after this it'll be 11, but it's comparing the value before the plus. By contrast, if you do this plus income greater than 10, then it will not be true. It will not execute the code. Frankly, I consider this ugly. I consider it dangerous. I consider it ill-advised. I believe it is hazardous to use these things. Why? Because, ladies and gentlemen, you want to be clear about where things are changing. You don't want it all wrapped up in some expression. Just simplify your difficulties. Do something like this. Modify income after this. Else this. Don't do it as part of the test, because you can easily miss that it's going on as part of the test, and you don't realize it's changing. It's just confusing. But just be aware that you can very nicely say it's equal to itself plus 1 very easily. So this guy is just exactly the same as this, which is exactly the same as this, like that. They're all the same. These last three are the same. They're all identical. It's just that we have a nice way of writing it quickly, to write it compactly. And someone glances at it, it's just this one. You kind of look at it, okay, is this the same as that? Oh, it's the same thing, so we're incrementing it. This communicates it on how much it's incrementing it by, and that it's incrementing that same variable by that. So those are things you'll see in some code with variables. So variables can exist at different levels, but I don't think I'm going to go into this. Okay, yeah, I was talking about these things. So you'll find a whole bunch of these: plus equals, times equals, divided by equals, minus equals. These are all sort of what you'd expect. A plus equals B means A equals A plus B. A times equals B means A equals A times B. A divided equals B equals A divided by B. You'll see all of these. They're fairly well represented in code. Okay. Yeah. This stuff. Sometimes there's some bad eggs out there who like to sort of delight in obscurity and in bad news. Try to make your models transparent. Okay. So these things can be applied very generally. I have some more slides in this that get a little bit arcane. I don't want to give it to you, but what's that?
Quick question. In the code, the Java code, are you able to make comments?
Yes. And not only can you, please make comments. Please make comments. How do you make them? There's actually two ways. One is you put this slash, and you put anything after that on that same line is a comment. It just ignores it. The compiler ignores it. We should pay attention to it. So this says drink if thirsty, if in water. That's what this means, and that's helpful to understand. Demolish trees at current cell, if any. That's what this is doing conceptually, and that's really useful. If you don't have comments in your code, often it's obscure for others to read it. It'll be obscure for yourself in a few months' time to read it. You say, what was I doing here? What did I mean to do? Comments are your way of communicating intention. What are you trying to do? What are you trying to do? This is about the how, but what are you trying to accomplish? Now, there's other ways to communicate that too. For example, if I were the person who wrote this, and I'm not, this came out of St. Petersburg, then I would actually have, if thirsty and is water, I'd have a function called is water, and I pass C and R, and it does this computation, and it hides that for me. I don't care what this thing is. I don't want to be looking at it. It goes off and does the computation. So comments aren't the only way, but they're one of the ways. The other way you can put comments in is by this, is by this sort of thing. So you can not only put them like this, comment, but you can have a long comment like this, longer comment, and it can go several lines long. It can go as long as you want or as short as you want. So I can actually do it within a given line, and then this is, some additional code here or something like that within a single line. One thing I will try to communicate, ladies and gentlemen, there's a convention. There are conventions in Java that that Java for Dummies will help you understand. But one of the key ones is to indent. Try to use indentation as your friend. Okay, indentation is key. But this will get me in the next lecture, which are in this in a moment here. So I'm gonna get rid of this promote me function because we're not gonna use that. But okay, yeah. Okay, variable scopes, yeah. Okay, right. Okay, suppose. Right. Right. Okay, this is important. This is a point of potential confusion. So suppose we have something. Suppose we have a reference to an agent A, okay, and that agent has a parameter, maybe it's a variable, maybe it's a parameter, either one, called mother. If we say, and suppose we have another reference to another person called M. If we say a.mother equals M, that person's mother the parameter will then refer to whatever M refers to. Alternatively, then I could say right after that, a.mother equals a certain person in the population. And that doesn't affect what M refers to. It sort of affects who A thinks their mother is. It doesn't change one referred to by M. So here's M. M originally referred to this certain person in the population. A referred to this person originally, and population referred to a sort of an array, a sort of set of information on successive people who live in the population. That's the population in Maine. We've been using that a lot, right? Population within Maine. That population group in Maine, we've asked for the flang, we've removed people from it, we've added people to it. So this is the population that we imagine by dragging over from person. Oh gosh. Sorry, folks. I don't know what's going on here. I don't know why this is running out of power. Oh gosh.
No pressure.
Oh gosh. Oh man. Sorry. Censored. Oh, it was just a beautiful point too. I had that nice diagram. Okay. Remember, these are just values. Assigning one value here, okay. So now we're assigning a different value. Which value is this going to be? Remember, it starts 0, 1, 2. So which value is it going to be? The third. Yeah, it's going to be this one here. And what's going to happen is what? What's going to happen is this just goes down here. And this one still is referring to that. That doesn't change at all. But this one no longer refers to that same person. This one, instead, their mother points them to here. Okay? Only can point to one thing at a time. Yeah. There's only one thing that it can refer to. Well, that's not so it just refers to them other than that one. The point is it's not modified in any way. It's not reverted by it anymore. and this guy still did that, it's fine. So, does that make sense to people? So after this, mother points, A's mother refers to this after that initial assignment, but then later, after this occurs, kind of write this, we should actually get to, I think, it refers down to this person here, the 0, 1, 2 person in that population. Does that make sense? People comfortable? Okay. Okay. So that's all I have to say on expressions. Can I show you statements now? We can actually get through this, I think, quite a bit quicker now that we've done this. So let's see. Oh.